Hey everyone, welcome. In this video, we'll be explaining the 6 simple machines. But before we get too deep, let's first get a general understanding of a machine. What is a machine? A machine is generally defined as a device that performs or assists in performing work. Machines can be mechanical or electrical or a combination of both. For the purpose of this video, we'll only focus on mechanical machines. Machines are generally designed to perform specific tasks, but no matter the design, they all share the same aspects. Some of these key aspects or functions of machines are: machines are used to transform energy from one form into another form, such as a generator converting mechanical energy into electrical energy. Machines are used to transfer energy from one place to another place, such as in engines where energy is transferred through mechanical components. Machines are used to increase force, such as in a pulley system where less effort is used to lift a heavy load. On the same note, they are used to increase speed, such as a bicycle increases speed by exerting greater force. And finally, machines are used to alter the direction in which a force is applied, such as a flagpole hoist, which changes the direction of force applied to raise or lower a flag. Now that we've defined what machines are, we can start talking about the various and basic forms of machines, also known as simple machines. There are 6 simple machines: the lever, the pulley, the wheel and axle, the inclined plane, the screw, and the wedge. With a combination of 2 or more of these simple machines, they can form what is called a compound machines. Let's go through each simple machines and define what they are. Since some of these simple machines are closely related to each other, we will combine some together when we define them to help keep the video short. Speaking of a short video, in this video we'll only cover 2 of the 6 simple machines, and in the next video we'll cover the rest. These videos take a lot of time to create, and to help deliver them faster, it's best to break them up when necessary, especially with large topics such as this one. So with that said, we'll start off with the lever as the first simple machines. Knowing how a lever works is critical to understanding more complex subjects such as aircraft weight and balance. So getting a good understanding of this topic will help in the long run. So what is a lever? The lever is the simplest machine out of the 6 simple machines. It consists of a rigid bar, which is the lever itself, that pivots at a fixed point. It amplifies an input force to lift or move a load. All levers have 3 main components. These components are the fulcrum, load, and effort. Let's describe each component in more detail. The fulcrum is the point on which the lever pivots or balances. It can be located anywhere on the lever depending on the type of lever. The resistance, which is also known as the load, is the weight or force that is being moved or lifted. The effort is the force applied to the lever to move the load. Another components we could add to this list are the lever arms. The lever arms, which are represented by L and I, are distances between the fulcrum and resistance, and the distance between the fulcrum and effort. Together, all these components is what makes a lever. There are 3 classes of lever, and they're classified based on the relative position of the fulcrum, the effort, and load. These classes of levers are first class lever, second class lever, and third class lever. Let's go over each type in details. In the first class lever, the fulcrum is between the effort and the resistance. An example of this type of lever would be a seesaw, crowbar, and scissors, where the effort and resistance are on opposite ends and the fulcrum is in the middle. This type of lever can provide mechanical advantage in terms of force or distance, but not both at the same time. If you notice, we just mentioned a very important term. That term is mechanical advantage. Before we go any further on levers, let's pause for a minute and define mechanical advantage. One of the core functions of a lever or any simple machine is that it provides mechanical advantage. To better clarify, mechanical advantage is a universal principle that applies to all simple machines. So mechanical advantage is defined as the ratio of the output force to the input force, or the output distance to the input distance. Or it can be summarized by the formula M8 equals output force over input force, or R over E, where R is resistance and E is effort. Remember at the beginning of this video when we listed the aspects of a machine? Well, all those aspects can be defined as mechanical advantage. Okay, let's go back to further explaining the lever. Since levers operate on the principle of mechanical advantage, all levers are calculated by the formula of L over I equals R over E. You may also see this formula be written as E times L equals R times I. They both are the exact same formula, just rearranged. Again, L is the length of the effort arm, I is the length of the resist arm, R is the resistance or load or weight, and E is the effort or the input force. Now that we've got a base understanding of levers, let's take this formula that we've just learned and apply it to a practice problem to demonstrate lever usage in aircraft components. Levers are used in aircraft components like control surfaces, where the pilot input is amplified to move large control surfaces. For example, a pilot is operating a Cessna 150 and deflects the elevator to adjust pitch during takeoff. The elevator is controlled by a belt crank, a first-class lever, with the following specification. The aerodynamic load on the elevator, which is the resistance, is 45 pounds. The distance from the fulcrum, the pivot of the belt crank, to the point where the elevator pushrod attaches, which is the resistance arm, is 4 inches. The distance from the fulcrum to the point where the pilot input pushrod attaches, which is the effort arm, is 12 inches. The system is in equilibrium when the elevator is deflected. Question: what is the effort in pounds must the pilot apply through the yoke via the cable to hold the elevator in this position? What is the mechanical advantage? To help solve the first part of this problem, let's start out by substituting the given values into the lever formula. From here, we cross multiply. We multiply the effort arm 12 by the effort E, and that will give us 12E. 12E equals the resistance 45 multiplied by the resistance arm of 4, which is 180. From here, we solve for E. We divide 12 on both sides of the equation, and that will give us E equaling 15. The pilot must apply an effort force of 15 pounds through the yoke via the cable to hold the elevator in this position. For the second part of this problem, since we know what the effort is, we can easily find the mechanical advantage by using the formula mechanical advantage equals R over E, which is force out over force in. We substitute 45 for R and 15 for E. When we divide, we get a mechanical advantage of 3 for this lever. In the second class lever, the resistance is between the fulcrum and the effort. An example of this type of lever would be a wheelbarrow, where the wheel acts as the fulcrum, the load is in the middle, and effort is applied at the handles. This type of lever always provides a mechanical advantage in terms of force, but not distance. In the third class lever, the effort is between the fulcrum and the resistance. An example of this type of lever would be the human arm, where the elbow is the fulcrum, the effort is applied by the muscles, and the resistance is the weight held in the hand. This type of lever provides mechanical advantage in terms of speed, allowing for quick movement but requires more effort. This concludes the discussion of one of the 6 simple machines. For the next type of simple machine, we'll be learning about the pulley system. Pulleys are simple machines consisting of ropes, wheels, or discs mounted on a fixed axis supported by a frame. The frame is referred to as a block. There are 3 main types of pulleys commonly recognized in mechanics and engineering: single fixed pulley, single movable pulley, and a block and tackle. Let's go over each one. A single fixed pulley essentially acts as a first-class lever with equal arms. The effort arm equals the resistance arm, and both equals the object weight. Because of this, the mechanical advantage of a single pulley is 1, meaning the force required to lift an object equals the object weight. The primary function of this type of pulley is to change the direction of the force applied. The second type of pulley is a single movable pulley. This type of pulley system acts as a second-class lever, with the resistance being at the center of the pulley, with both the fulcrum and effort being at the rope of the pulley. The effort arm being the diameter of the pulley and the resistance arm being the radius. This type of pulley is attached to the load itself and moves with the load as compared to the single fixed pulley where only the load moves when the ropes are pulled. The mechanical advantage of a single movable pulley is 2. The effort needed to lift a load is always half of the load weight being lifted. For example, if a 600-pound engine was to be lifted using a single movable pulley system, the effort needed to lift the engine would be 300 pounds. The primary trade-off in this type of pulley system is that the rope must be pulled twice the distance to move a load. If a load has to be lifted 5 feet, 10 feet of rope must be pulled to get the load to the required distance. The last type of pulley we'll talk about is the block and tackle pulley system. This type of pulley is made of multiple pulley system. It is a combination of both a fixed pulley and a movable pulley. In this example, the top 2 pulleys are fixed and the bottom 2 are movable. The mechanical advantage is determined by the number of supporting ropes. In this example, the system has 4 ropes, so therefore the mechanical advantage will be 4. A 600-pound load will only require 150-pound effort because 600 divided by 4 is 150. This concludes part 1 of this video. Part 2 should be coming out soon, so make sure to subscribe to get notified when it comes out. Thank you for watching. Hope to see you in the next video.